Hi guys, welcome to Learn Networks. In our last lecture, we saw about the VXLAN on the Ingress replication static. So today we are going to see about the multicast flood and learn. So how it is different from the Ingress replication. Last class we saw the Ingress replication, like any broadcast traffic received on the leaf one, the leaf one we're going to send it as a unicast to the other VTEPs. So this is how, like, they receive it as a unicast, then the ARP request will be sent to the PC2, and we get the unicast ARP reply. This works in the Ingress application static based on the configuration on the NVE. So now we are going to use our multicast as our overlay protocol, where the source would be the NV interface, loopback 0 of the leaf 1, and the destination would be the multicast IP what we assign. So that's going to be the multicast address for the first packet, and all the subsequent packet. Once it learns the VTEP, it learns about the VTEP. So all the subsequent packet will be unicast. So in the previous session, the configuring peer IP is going to be really tough in the large scale. So if you have a 200 leaves and we need to configure statically for each and every leaf about each and peer leaves about in all the 200 leaves, that's not going to work out. So here, like, to overcome that, we have got the solution, which is the multicast flood and learn. So let's jump on, let's have a packet capture analysis as well with this. So first, let us enable, it's going to be the same setup what we have done now. Right now we don't even have the NV interface. This is a spine 1, spine 2, and leaf 1, leaf 2, and the PC1, PC2. Okay, right. So this is a PC1 and PC2. So first, let's do this in a notepad. Okay, so first, we are going to, on the spine 1, we are going to enable feature PIM. Okay, so and the spine 1 is going to act as the RP address. So just keep a note that the prerequisite to know about this is we should have a little knowledge on the multicast. Please post your comment in the comment section, that if you really need a multicast session to be taken, so I can add that in future videos. Okay, so feature PIM needs to be enabled, and feature fabric forwarding should be enabled. So excuse me if there is a spelling mistakes. I use question marks in my commands. Then this is on the spine 1. We have already underlay setup, OSPF, everything is there, and we are able to reach the loopbacks, everything. So probably I can show you. Then in the spine 2, okay, then okay, fine. In the spine 2, we configure the same thing, config T, feature PIM, then feature fabric forwarding, and in the leaf, now comes the picture. So feature NVE overlay, where we have the NVE feature VN segment. I forgot that command. Feature, I'm sorry, bad in commands. Feature NV overlay VN segment based VLAN. Okay, VN segment VLAN based. VLAN based. So this is for the VNI to VLAN mapping. The NV overlay is for the creating the NV logical interface. And we need to enable feature PIM. Okay. So now what we are going to do in the interface NV1, we are going to mention the source MAC address, source interface loopback 0. Okay, let's make loopback 1. Okay, I have mentioned, have like dedicatedly made a loopback 1 with no reasons probably, and the member VNI with, let's say, 150.140, what we have used in the last class. We use the same thing with mcast address. We give our multicast address, probably 228.0.0.140. Okay, so this is what the configuration on the NV interface, and we need to enable the PIM on all the L3 interfaces. Okay, so probably we can jump into the lab rather than configuring it in the notepad, so that will be little realistic. So go to config terminal, feature PIM. Okay, it takes time. Okay, feature fabric forwarding. Yeah, right. Feature fabric forwarding. Okay, then we configure on the spine 2, we configure the same admin. Okay, config T, feature PIM. Okay, then feature fabric forwarding. Then let's get into the leaf. Let's configure feature PIM, feature NVE, NV NV overlay EVPN. This is the one, not the one. Feature NV overlay. Right, I was right. Okay. Then in leaf 2, feature. Okay, I'm sorry. Config T, feature PIM. Feature NV overlay. So now we configured a feature and PIM. Okay, then we missed to configure feature VNI segment VLAN based, and here feature VN segment VLAN based. This is for the VNI to VLAN mapping, VLAN to VNI mapping. Okay, so now let's configure all the interfaces with the PIM. Okay, show IP interface brief. So to make the things easy, interface IP PIM sparse mode, and in the interface 1/2 IP PIM sparse mode. And we have to give in the sparse mode, we need RP address to be configured. The RP address is, let's make 0.1 as our RP. IP PIM RP address 192.168.0.1 for the group placed 228.0.0.0/24. So the multicast, we specify the multicast group. So for this particular multicast group, the RP address is going to be 192.168.0.1 bidirectional. So to understand the multicast better, so better to have a multicast session separately. So probably I can try to cover that multicast separately. So then moving further, let's configure on the spine 2. Show IP interface brief. So in interface is 1/1 IP PIM sparse mode. Interface is 1/2 IP PIM sparse mode. IP PIM RP address 192.168 group list 228.0.0/24 bidirectional. Okay, so then in the leaf switch, let's give show IP interface brief. So in that, okay, I missed it. So we need to give the RP address also to be part of the PIM, IP PIM sparse mode. I'm sorry for that. Okay, fine. So interface is 1/2 IP PIM sparse mode 1/interface 1/3 IP PIM sparse mode. And now we need to configure the loopback 1, which is going to participate in the NV interface source, probably like tunnel source interface. So that should also be there in the sparse mode. So even the loopback 1 should be there on the sparse mode. So since we are going to use the VTEP IP as the loopback 1. So here we have already enabled show IP interface brief config T interface Ethernet 1/1 3 IP PIM sparse mode interface 1/4 IP PIM sparse mode. So now here we are going to use the same loopback 1 and we create IP PIM sparse mode for it. And I missed it. IP PIM RP address, we have to mention the RP address as 192.168.0.1 for the group list 228.0.0.0/24 as a bidirectional. So the bidirectional PIM is basically like so the source can be anything. So in a multicast group, we have a group who is the destination, and the source is going to be the going to be a sender. So now ideally speaking, in a normal multicast, unidirectional multicast, we are going to receive a S comma G entries in our M routing table, whereas in bidirectional we are going to have only star comma G, because the source can be anyone. We don't know the source here. So now let's configure the same thing on the um, let's configure the same on the leaf one. So to verify this command, let's have show IP route. Yes, we have got this as a bidirectional, and we are able to see the RPF neighbor loop back, and show IP route, right, and show IP RP. Okay, yes, we are able to see that. We are able to see 192.160.1 is the RP address for the group 228.0.0/24. Show IP PIM neighbors. Okay, we are able to see the two, as well as show IP PIM neighbors. We should be able to see two neighbors formed. Okay, fine. So let's jump into the by creating the NV interface. Since we already created a enabled the feature for NV, let's config T NVE1. Now we go ahead and provide. Okay, uh, before that, let me create the VNI. I haven't created, I guess so. Okay, show VLAN. I don't see that VLANs. Show VLAN ID 140. Okay, it is not there. VLAN 140 VN segment 50140, and in the leaf 2 we create the same thing, VLAN 140 VN segment 50140. Now let's configure the NV interface. Config T interface NV1 source loopback 1 and member VNI 50140 MCAST group 228.0.0.0.140. Same way, and this, let's create interface NV1 source interface loopback 1 and VN segment, sorry, member VNI 50140 MCAST group 228.0.0.140. Okay, so no shut and no shut. Okay, so now let's have a look at the RP show IPM route. We can see there is an entry created for 228.0.0.140. Okay, so by default, like there will be a PIM register will be sent by both the leaf switches towards the RP. So both are ready. That's why we are able to see them on the both the interfaces. So we can see that from 1/2 as well as from the 1/1. So Now let's jump into the PCs. Before I wanted to show you from the PC side, I wanted to ensure that I capture the ARP packet directly. So show run interface Ethernet 1/1. It's being part of the VLAN 140. First, I'll shut it because I haven't assigned the IP address for the. This would I wanted to capture the broadcast traffic so that we can see the broadcast is getting translated as the uh, multicast. The reason behind I'm shutting is so the moment I assign the IP address on the PC, it does the duplicate detection. So at the time the ARP will be learned and ARP will be sent and it will learn the MAC address table will get populated. So before that, let me check what is that IP address mentioned over there? No, there is no IP address. I'm sorry. IP 171 dot, what is that IP segment? 171.21.140.10/24. It check the duplicate address. So however since we have shut that, that will not be sent over the interfaces. IP 171.21.140.20/24. Okay. Okay, fine. Now let's go and give no shut and no shut. Okay, and before that, let's do a capture. Let's capture the interface Ethernet 1/3 and Ethernet 1/2. So now we have two captures running parallelly. They're going to capture the those interfaces. So let me initiate a ping from the PC1 towards the PC2. Ping 172.21.140.20-T. So the first packet going to be failed and the further it's going to ping. Okay. So let's analyze the packet capture. Let's stop from both. So let's search for the ARP request. Okay. So if you see in this is the ARP request. So this is the outer header where it has the source MAC address as the leaf1 MAC address and the destination MAC address is the leaf2. And if you see this, we can see the source IP address as the 192.160.13 and the destination is the 228.0.0.140, which is the multicast. Then coming down, it's going to be the UDP 5326 and 4789, which is a VXLAN port, default port, and this is a VXLAN encapsulated packet. And within that, if you can see the source MAC address as the PC1 MAC address, this is the inner header where it has the broadcast MAC address to identify the ARP request. This is the ARP request which is in the inner MAC address. So the ARP request is I am the sender IP, which is 171.21.140.10, and my destination IP is 171.21.140.20, and what is the MAC address of the 140.20. So this has been sent as the broadcast. So so the same thing happens since this is the equal cost load balancing. We expect the same thing on the other packet capture as well, like other interface as well. So there is an R, this source, and destination MAC address is the inner header, and if you see it in the outer header, this is going to be the same. So however, we are able to successfully ping between these two PCs, and if you go ahead and check on the MAC address table, show MAC address table, you don't see the MAC address table on the spine switches. Rather, we would be able to see show MAC address table. You can see the remote peer IP has been learned, peer MAC address, I'm sorry, peer MAC address has been learned via the NV interface. So the source MAC address from Ethernet 1/1 and the destination MAC address is going to be go via the NV interface. Since this is going to be encapsulated via the spine would never learn any MAC addresses on its MAC table. Thanks for watching. Please let us know if you need any improvements, and this is going to be my first time doing a video, so comment your feedback on that. Thank you very much.